We are now going to study a specific discrete probability distribution function known as a binomial distribution. And here's a typical example of such. Ben Simmons is a promising young point guard on the Philadelphia 76ers, but he's an awful free throw shooter. He makes approximately 60% of all the free throws he shoots. Remember, this is all relative. 60% would be quite good for me. This is a professional basketball player. If he were to take 10 free throws, what's the likelihood he'll make 7 of them? Again, the free throw is the special line where you get to shoot without anybody bothering you, right in front of the basket there. While technically we have discussed all the counting techniques needed to do a problem like this, you have to actually use several of them and combine them in a more complicated way. So instead of figuring out exactly how to do that, we're going to talk about how we can identify this as a binomial distribution problem, and then we're going to have a specific formula or table that we can read to answer this. So first, let's find out what is the criteria for a binomial distribution. A binomial probability experiment must satisfy 4 conditions. They are, number 1, and there's no particular order to them, it's got to be a fixed number of trials where each trial is independent of the others. Number 2, 2 possible outcomes for each trial, denoted success or failure. So there's only 2 possible outcomes, hence the reason it's called binomial, bi representing 2. Number 3, probability of success is same for each trial. And number 4, the random variable x counts the number of successful trials. We will look back at the Ben Simmons problem to see how it satisfies these conditions. But before that, there's some very important notation that you need to know. In order to use the formula, you have to know what the variables represent in the formula. So they are, n represents the total number of trials of the experiment, p is the probability of success on a single trial, q represents the probability of failure on a single trial, and x is the number of successes in n trials. And it's also important to note that since there's only 2 possible outcomes, and p is the possibility of success and q is the possibility of failure, then that p plus q must add to 1. Let's now look back at the Ben Simmons example and see how these conditions are satisfied and what the values of the variables are in this particular case. Again, let's quickly reread through the problem. Point guard Ben Simmons is an awful free throw shooter. Through his young career, he's made approximately 60% of his free throws. If he were to take 10 free throws, what's the likelihood he'll make 7 of them? So first, how do I know this is a binomial distribution problem? Well, again, there's 4 conditions that need to be met, but there's really a couple of key things that you need to focus in on. First, are there only 2 possible outcomes in this experiment, making it binomial? And there is, because we're talking about him shooting free throws, and he either makes or misses. He either makes or misses. Hence, it's binomial. Then the other parts of it, we're going to sort of assume are okay. For example, he's a 60% free throw shooter. If he were to miss 5 free throws in a row, maybe his 6th free throw would have a lower percent chance of making it, because maybe his confidence has been hit. Or if he's taken a lot of them, perhaps he's getting tired. But we're going to assume that each time he takes a free throw, it has a 60% chance of going in. So each trial has the same likelihood of success. Technically, all 4 conditions must be met, but the key thing that you really need to check is to make sure there's only 2 possible outcomes and that there's the same likelihood of success on each of the trials. Let's now go through and see if we can find the values of the variables. So first, n represents the number of trials. So how many experiments is he performing? Well, he's taking 10 free throws, so n is 10. Then p represents the likelihood of success on a single trial, so not overall, on a single trial. And it says right here, his likelihood of success on a single trial is 60%. Don't forget, don't put in the number 60. 60% is 0.6. Now, Q is not given directly in the problem. However, we know the relationship between P and Q is that they need to add to 1. So if P is 60%, then Q must be 40%, or 0.4. Then finally, X represents the number of successes. And he's doing 10 trials. We want there to be 7 successes. What's the likelihood he'll make 7 of them? Notice that I assigned the probability of making it to be P. You could have technically done that as Q. it really doesn't actually matter. There is no judgment about what's successful and what's not. However, I consider make being the success and missing being the failure, hence the reason the 60% is here and the 4% is here. Now that we have the values of the variables, which you can see here, we can now use this special formula to find the probability that Ben Simmons will make 7 of the 10 free throws. The binomial probability formula says the probability of exactly x successes in n trials is P of x is n choose x times p to the x power times q to the n minus x power, where n, x, p, and q are defined as we said over here. So let's now use this formula to find the likelihood that Ben Simmons will make 7 of his 10 free throws. We'll plug everything in, and then ultimately we'll plug that into the calculator to do the computation. So we want the probability that Ben Simmons will make 7 baskets. So P of 7 is equal to n is 10, so it's 10 choose x is 7, 10 choose 7 times P is 0.6, and we now need to raise that to the x power. And again, x is the number of successes. We want 7 of them, so we raise it to the 7th power, times q, which is 0.4, to the n minus x power. Of course, n minus x is 10 minus 7. Of course, you could write in 3 right away there. I just want to make sure it's clear where everything came from. So let me just put those bases in parentheses so you can clearly see this. So the likelihood that Ben Simmons will make 7 of the 10 free throws is 10 choose 7 times 0.6 to the 7th power times 0.4 to the 3rd power. I would not plug that in the calculator like that just to avoid any potential error, just plug in actually 3. I actually also suggest plugging in the entire expression into the calculator at once instead of doing it in 3 separate parts, because if you have any rounding in, say, either of these, and then you do additional computations on top of a rounding, you could potentially make the rounding error larger. So plug in this entire thing at once in the calculator if you can. And if you do that, we get the probability that Ben Simmons will make 7 of his 10 free throws is approximately 0.215, or 21.5%. You may look at that and say, wow, that's not very good. And it's not very high. But also remember, he has a probability of making 6 or 8 or 5 or 9 or 4 or 10 or 3 or 2 or 1 or 0. So it shouldn't be terribly surprising that that percentage is not very large. Before we look at an additional problem, let me just quickly explain a little bit where this formula comes from based on our counting techniques. So when Ben Simmons shoots his 10 shots, do you care when he makes the 7? Does it need to be the 1st, the 3rd, the 4th, the 5th, 6th, 7th, and 9th? No, we just need him to make exactly 7 of them. That's the reason that you see the n choose x part in here. Because with n choose x, the order doesn't matter, so we don't care where they occur. And then you have these multiplications in here because ultimately this is essentially a multiplication rule problem. You want the probability of him making 7 successes, so a success and another success and another success 7 times. And then you also want him to fail 3 times, so and a failure and another failure and another failure. But then again, the reason that this part is in there is because we don't care where those 7 successes occur or those 3 failures occur. Some of you may be thinking, well, what if he made more? Technically for the team, that would be great. So shouldn't the question be, what's the likelihood he'll make at least 7 of them? That is a very legitimate question and it is something that we will address in the next screencast.